class we'll uh, discuss the method to find the radius of Bohr orbit. Okay, yesterday we calculated the velocity of an electron in Bohr orbit, radius of Bohr orbit. Okay, so Bohr orbit means there are some specific orbits in which the angular momentum of the electron is an integral multiple of h by 2 pi. Such orbits are called stationary orbits. So the first condition that should be satisfied is MVR, angular momentum is nh by 2 pi. Equation 1. Then for any circular orbit, the centripetal acceleration will be there, and here it is provided by the Coulomb force of attraction between the nuclei, which has a charge Ze, where Z is the number of protons or atomic number, into electronic charge E divided by R square. Okay, so if R is the radius of an orbit, then the necessary centripetal force is given by mv square by R. Here the only agency which can provide that centripetal force is the Coulomb attraction between nuclei and the electron. So we got two equations, and from this equation, R is equal to, from the first equation, R is equal to nh by 2 pi mv. R is equal to nh by 2 pi mv. But we already have an expression for velocity. V is equal to, thus that Z is square divided by 2 epsilon 0 nh. That you will get by simply dividing 2 with 1. Equation 2 ne 1 കൊണ്ട് divide ചെയ്താൽ you will get this expression. We already derived this yesterday. Then V is equal to Z E square divided by 2 epsilon 0 nh. Okay. So velocity of electron in Bohr orbit. So substitute back in this expression. R is equal to the V യുടെ value ഇവിടെ കൊണ്ട് substitute ചെയ്യാം. So that will become nh divided by 2 pi m into V is Z E square divided by 2 epsilon 0 nh. Okay. This 2 will cancel. 2 will cancel. Epsilon 0 nh will go to the numerator. So you will get epsilon 0 n square h square. Epsilon 0 n square h square divided by ബാക്കി എന്താ ഉള്ളത് pi m z e square. So velocity, you substituted this value, then you obtained the radius of Bohr orbit as epsilon 0 n square h square by pi m z e square. For hydrogen atom, radius of first orbit എത്രയായിരിക്കും വരിക? ഹൈഡ്രജൻ ആറ്റം എന്ന് പറയുമ്പോൾ ഉടനെ നിങ്ങൾ എന്താ ചെയ്യേണ്ടത്? Put Z is equal to 1. So Z is equal to 1, hydrogen atom. Radius of first orbit means N is equal to 1. N is equal to 1. So this is R, denote it as R0. R0 is epsilon 0, n square becomes 1 square, h square divided by pi m e square. Z is also 1, n is 1. And if you substitute the values of epsilon 0, h, pi m and e, where m is mass of electron, you will get it as something like 0.59 nanometer. Okay. So this is a radius of first orbit of hydrogen atom. Then general expression you can write it as Rn is equal to Z square, n square divided by Z, n square divided by Z into R naught, n square divided by Z into R naught, and R naught is this value. So the radius of an orbit will be of the order of few angstrom, okay, or it is of the order of 10 raised to minus 10. ഒരു ആറ്റത്തിന്റെ റേഡിയസിന്റെ ഓർഡർ എന്ന് പറഞ്ഞാൽ 10 raised to minus 10ന്റെ ഓർഡറിലാണ്. ഇത് ഉപയോഗിച്ച് നിങ്ങൾക്ക് ഏത് ഓർബിറ്റിന്റെ, അതായത് ഫസ്റ്റ് ഓർബിറ്റ്, സെക്കൻഡ് ഓർബിറ്റ്, അങ്ങനെ ഏത് ഓർബിറ്റ് കാണണമെങ്കിലും നിങ്ങൾ എന്നിന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. സെഡ് എന്ന് പറയുന്നത് ആറ്റത്തിന്റെ അറ്റോമിക് നമ്പർ ആണ്. സോ ഇവിടെ നിന്ന് എനിക്ക് രണ്ട് കാര്യങ്ങൾ പറയാം. ആസ് സെഡ് ഇൻക്രീസസ്, that is, as you move from hydrogen to sodium to uranium, okay, as the Z value increases, radius of the orbit decreases, okay, because as the number of protons in the nuclei increases, there is a huge force of attraction to the electron, so the radius of the orbit will be small. Now as n increases, radius of course will increase, okay. So we can calculate the radius of few atoms, find radius of second orbit of the beryllium atom. So what will be the answer? Here, find the radius of second orbit of beryllium atom. Okay. This is right, actually 0.529, and this is not nanometer, this is angstrom. Okay, please correct it. 0.529 angstrom units ആണ് ബോർ റേഡിയസിന്റെ വാല്യൂ എന്ന് പറയുന്നത്. ഓക്കെ, അതാണ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യേണ്ടത്. സോ ഹിയർ യു ഹാവ് R is equal to the equation is n square by Z into 0.529 into 10 to the power minus 10. Angstrom എന്ന് പറഞ്ഞാൽ minus 10 ആണ്. Okay, angstrom എന്ന് പറഞ്ഞാൽ minus 10 ആണ്. So here n is equal to 2 second orbit, Z is equal to beryllium atomic number is 4, so R is equal to n square, 4 by 4 into 0.529 into 10 to the power minus 10 meter, and it is simply 0.529 into 10 to the power minus 10 meter. This is the radius of second orbit of beryllium atom. Now find radius of third orbit of the carbon atom. Will be the answer. ചെയ്തിട്ട് പറയാ ആൻസർ എത്രയായിരിക്കും വരിക? R is equal to 3 square, okay, third orbit 3 square, carbon atom atomic number is 6 into 0.529 into 10 to the power minus 10 meter. 3 square is 9, 9 by 6 is 3 by 2, it is 1.5 into 0.529 into 10 to the power minus 10 meter. Okay, so we can calculate the radius of any orbit of any atom. Okay, നിങ്ങൾ ആകെ ചെയ്യേണ്ടത് എന്താണ്? 0.529 into 10 raised to minus 10 is called Bohr radius. Okay, Bohr radius എന്നാണ് ആ വാല്യൂ അറിയപ്പെടുന്നത്. ഇത് ഷോർട്ട് ക്വസ്റ്റ്യൻ ആയിട്ട് ചോദിക്കാറുണ്ട്. Bohr radius എന്ന് പറയുന്നതാണ് ഹൈഡ്രജൻ ആറ്റത്തിന്റെ ഫസ്റ്റ് ഓർബിറ്റിന്റെ റേഡിയസിനെയാണ് Bohr radius എന്ന് വിളിക്കുക. ഇറ്റ് ഈസ് ദ റേഡിയസ് ഓഫ് ഫസ്റ്റ് ഓർബിറ്റ് ഓഫ് hydrogen atom. radius of first orbit of a hydrogen atom. ഏറ്റവും ലൈറ്റർ ആയിട്ടുള്ള ആറ്റം ആണ് ഹൈഡ്രജൻ. അതിന്റെ ഫസ്റ്റ് ഓർബിറ്റിലുള്ള റേഡിയസിനെ, ഫസ്റ്റ് ഓർബിറ്റിന്റെ റേഡിയസിനെയാണ് ബോർ റേഡിയസ് എന്ന് അറിയപ്പെടുന്നത്. ആൻഡ് ഇറ്റ് ഈസ് 0.529 ആങ്സ്ട്രം. ഇത് ഷോർട്ട് ക്വസ്റ്റ്യൻ ആയിട്ട് 1 മാർക്കിന് ചോദിച്ചിട്ടുണ്ട് ഈ വാല്യൂ മാത്രമായിട്ട്. വാട്ട് ഈസ് ബോർ റേഡിയസ്? ഓർ അതിന്റെ വാല്യൂ മാത്രം എഴുതിയാൽ തന്നെ യു വിൽ ഗെറ്റ് 1 മാർക്ക്. ഓക്കെ, സോ ഇറ്റ് ഈസ് ഓഫ് ദി ഓർഡർ ഓഫ് ആങ്സ്ട്രം. ഓരോ എലമെന്റ് മാറുമ്പോഴും അല്ല ഓരോ ആറ്റം മാറുമ്പോഴും അതിന്റെ ഓർബിറ്റ് നമ്പർ മാറുന്ന സമയത്തും ഇതാണ് അതിന്റെ വേരിയേഷൻ. എനി ഡൗട്ട്?
ഇല്ല സർ.
We got radius, we got velocity. You can calculate time period also, 2 pi r by v, and reciprocal will give you frequency. Okay, and then kinetic energy. Kinetic energy. Kinetic energy is half mv square. We already have the equation for v as e square z e square divided by 2 epsilon 0 nh. Okay, so k becomes half m z square e raised to 4 divided by 4 epsilon 0 square n square h square. Okay, so solving, you will get m z square e raised to 4 divided by 2 into 4, 8 epsilon 0 square n square h square. This is the expression for kinetic energy. So I can write kinetic energy as proportional to z square by n square. Kinetic energy is proportional to z square by n square. So we have a velocity proportional to z by n, radius proportional to z square, sorry, n square by z, and now kinetic energy proportional to z square by n square. So these dependents are very important. Okay, and you can also calculate the starting value. That is, by putting z equal to 1, n equal to 1, you can find the constant value. In the case of velocity, it was c by 137 or alpha c. Alpha is called fine structure constant. In the case of radius, that constant is called Bohr radius. Its value is 0.529 angstrom. Okay, for kinetic energy, it is not usually calculated, but for total energy, we will calculate that constant value. Okay, so next I will calculate potential energy. So kinetic energy, we already obtained an equation. Potential energy. Here, there is Coulomb force between nuclei and electron. So the potential energy will be of electrostatic nature. Electrostatic potential energy, you have the expression 1 by 4 pi epsilon 0 q1 q2 divided by r. In this case, the charges are respectively charge of nuclei Ze into charge of electron E divided by r. But this is Ze square by 4 pi epsilon 0. What is r? We already obtained expression for r as epsilon 0 n square h square divided by pi m z e square. So substitute that value of r, epsilon 0 n square h square divided by pi m z e square. So potential energy is equal to, this pi will get cancelled with this pi. This m will go to the numerator. So you will get an m in the numerator. Z and this z becomes z square in the numerator. Here an e square and this e square becomes e raised to 4 in the numerator. Divided by, you have 4 epsilon 0 square n square h square. So this is the expression for potential energy. This is expression for kinetic energy. Again, potential energy is also proportional to z square by n square. So dependence on z and n is same as that of kinetic energy. It is z square by n square. Now you can calculate the total energy of electron in Bohr orbit, total energy of electron in Bohr orbit. Bohr orbit. Bohr orbit means there are certain specified orbits in which angular momentum is an integral multiple of h by 2 pi. That is called Bohr orbit. They are called stationary orbits. So total energy is kinetic energy plus potential energy. What is kinetic energy? Pi mz square e raised to 4. There is no pi. Mz square e raised to 4 divided by 8 epsilon 0 square n square h square. Here we should put minus e for electronic charge. When we consider forces, we didn't put that minus sign. Force എടുത്തപ്പോൾ നമ്മൾ മൈനസ് സൈൻ ഒന്നും ഇട്ടില്ല. 1/4 ZV into E by R square എന്നാണ് എഴുതിയത്. Because force is a vector quantity. അപ്പൊ അതില് നെഗറ്റീവ് ഒക്കെ ഉണ്ടെങ്കിൽ തന്നെ അത് അട്രാക്ഷൻ എന്നുള്ള രീതിയിൽ റിപ്പൽഷൻ എന്നുള്ള രീതിയിൽ അത് റിഫ്ലക്ട് ചെയ്തോളൂ. ബട്ട് when you deal with a scalar quantity, if there is a negative sign, you have to put it explicitly. നിങ്ങളൊരു സ്കാലാർ ക്വാണ്ടിറ്റി ആണ് പറയുന്നതെങ്കിൽ നെഗറ്റീവ് ഉള്ളത് നെഗറ്റീവായിട്ട് തന്നെ ഇടണം. ഒരു വെക്ടർ പറയുന്ന സമയത്ത് നെഗറ്റീവ് സൈൻ ഇട്ടില്ലെങ്കിലും ദാറ്റ് വിൽ ഓട്ടോമാറ്റിക്കലി റിഫ്ലക്ട് ഇൻ ദ ഡയറക്ഷൻ. നെഗറ്റീവ് വന്നാൽ ഇറ്റ് വിൽ ബി അട്രാക്ഷൻ, പോസിറ്റീവ് വന്നാൽ ഇറ്റ് മീൻസ് ഇറ്റ് ഈസ് എ റിപ്പൽഷൻ. അപ്പൊ അവിടെ നമ്മൾ പ്രത്യേകിച്ച് മൈനസ് ഇടേണ്ട കാര്യമില്ല. ബട്ട് വെൻ യു ഡീൽ വിത്ത് energy, scalar quantity, you have to put that minus explicitly. So this is negative, right? So potential energy is minus m z square e raised to 4 divided by 4 epsilon 0 square n square h square. ഇതെങ്ങനെയാണ് സബ്ട്രാക്ട് ചെയ്യുക? Take all the common terms outside. Mz square e raised to 4 divided by epsilon 0 square n square h square. ഇത്രയും കോമൺ ആണ്. Remaining is 1 by 8 minus 1 by 4. So this is mz square e raised to 4 divided by epsilon 0 square n square h square. 1 by 8 minus 1 by 4 is LCM is 8. Here you have 1. The second time you will have 2. So final expression for total energy of electron in Bohr orbit is minus m z square e raised to 4 divided by 8 epsilon 0 square n square h square. This is very important expression. Okay. E is equal to, ഇത് വെച്ചിട്ട് ഒരുപാട് പ്രോബ്ലംസ് ഒക്കെ ചോദിക്കാറുള്ളതാണ്. E is equal to minus m z square e raised to 4 divided by 8 epsilon 0 square n square h square. So I can write E proportional to again z square by n square. Kinetic energy proportional to z square by n square ആയിരുന്നു. Potential energy proportional to z square by n square ആയിരുന്നു. So here total energy is also proportional to z square by n square. Now what is energy of electron in first orbit of hydrogen atom? First orbit of hydrogen atom. അതാണ് നമ്മൾ എപ്പോഴും ആ കോൺസ്റ്റന്റ് ആയിട്ട് എടുക്കുന്നത്, അല്ലേ? വെലോസിറ്റി പറഞ്ഞപ്പോഴാണെങ്കിലും വെലോസിറ്റി ഓഫ് ഇലക്ട്രോൺ ഇൻ ദി ഫസ്റ്റ് ഓർബിറ്റ് ഓഫ് ഹൈഡ്രജൻ ആണ് പറഞ്ഞത്. റേഡിയസ് പറഞ്ഞപ്പോഴാണെങ്കിലും ഇറ്റ് ഈസ് ദ റേഡിയസ് ഓഫ് ഫസ്റ്റ് ഓർബിറ്റ് ഓഫ് ഹൈഡ്രജൻ ആറ്റം, ദാറ്റ് വിൽ ബി ദ കോൺസ്റ്റന്റ്. ഹിയർ ഓൾസോ the energy of electron in the first orbit of hydrogen atom you can calculate, and it is found to be minus 13.6 electron volt, where 1 electron volt is 1.6 into 10 to the power minus 19 joule. So energy stand SI unit is joule, but in spectroscopy the energy will be very low. Usually the energy will be very low, so we will use electron volt as units. So energy of electron in the first orbit of hydrogen atom is minus 13.6 electron volt. Okay, then we can write E as minus 13.6 z square by n square EV. This is the expression for energy that you can use. So you can calculate, find energy of electron in second orbit of hydrogen atom. Second orbit of hydrogen atom. Answer answer. Still the atom is hydrogen. So Z is 1. Orbit is second. So N equal to 2. Therefore, E is equal to minus 13.6 divided by 4. It is minus 3.4 electron volt. Okay. Find energy of electron in third orbit of hydrogen atom. Third orbit of hydrogen atom. That is it. Third orbit of hydrogen atom. Again, Z is 1, N equal to 3, E equal to minus 13.6 divided by 9. It is equal to minus 1.51 eV. Again, you can calculate the energy of electron in fourth orbit of hydrogen atom. What is it? Fourth orbit of hydrogen atom. Z is 1, N is 4, E is minus 13.6 divided by 16. It is minus 0.86 electron volt. Okay. Is it clear?
Yes, sir.
Now, we can draw the energy levels. We can draw the energy levels of hydrogen atom. So, we are concentrating only in hydrogen atom now. Hydrogen atom. So, if you draw a graph, something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So if you draw a graph like this is 0 and downward direction is negative, Okay, in this axis you have energy. This is 0 of energy, downward direction it is negative. So for the first orbit of hydrogen atom, you have minus 13.6 eV. That will be something like this. This value is minus 13.6 electron volt. And this is for N equal to 1. N equal to 1. Now, if you consider the second energy level or second orbit, it is, we already calculated, minus 3.4. Minus 3.4 will be 1, 2, 3. 3.4 will be somewhere here. Is it clear? Minus 3.4 electron volt, and this is for N equal to 2. Now, again, you have for N equal to 3, it is minus 1.51, 1.51, so it will be somewhere here. This is minus 1.51 eV. This is for N equal to 3. For N equal to 4, you have 0.86, 0.86 minus 0.86, N equal to 4. Then you will have, for N equal to 5, you will have 1 by 25. So 13.6 divided by 25 means it will be little bit higher than 0.5. 0.5, so it will be somewhere here. Okay, then this will be closely spaced. As you move higher and higher, this will be closely spaced, and it reaches the zero level only for n equal to infinity. It reaches the zero level only for n equal to infinity. This is n equal to infinity, and this energy value is zero. Okay, so all the other energy levels will lie between these very small energy range. So initial spacing is very high. What is the spacing? What is the spacing? What is this spacing? What is this value? Anyone? This is 10.2, because 13.6 and 3.4 difference will be 10.2. So when an electron jump from this n equal to 2 level to n equal to 1 level, it will emit a radiation which is of 10 raised to 10.2 electron volt. 10.2 electron volt. Is it clear?
Oh, sir.
So that is the way in which we can explain spectrum, line spectrum. So hydrogen, if you observe the spectrum of hydrogen, it will have different lines, and one of the line will be at this position, 10.2 eV. What are the other possibilities? There may be transitions from this level to this level, that is n equal to 3 to n equal to 1. There may be transition from n equal to 4 to n equal to 1. There may be transition from n equal to 5 to n equal to 1. There may be transition from n equal to 6 to n equal to 1. Okay, this all these are possible transitions. All these are possible transitions. All these are to the state with n equal to 1. That is called the ground state. Okay, all these are excited states. All these are excited states. These are called excited states, because for hydrogen there is only one electron. For hydrogen there is only one electron. So usually it will lie in the level n equal to 1. This is called the ground state. When it got some energy, from somewhere, it will go to the higher energy states. Then it can come back to the ground energy by emitting a radiation. If it absorbs some radiation, അത് താഴെ നിന്ന് മുകളിലേക്ക് പോകും. If it emits some radiation, it will jump from a higher level to lower level. Okay, so I will explain a hydrogen spectrum. Hydrogen spectrum. We have En is equal to minus m z square e raised to 4 divided by 8 epsilon 0 square n square h square. For a hydrogen, z equal to 1. Okay, consider two orbits with n equal to n1 and n equal to n2. രണ്ട് ഓർബിറ്റ് കൺസിഡർ ചെയ്യുക. n equal to n1 ഉം n equal to n2. നമ്മൾ കൺസിഡർ ചെയ്യുന്നത് ഹൈഡ്രജൻ ആറ്റമാണ്. സോ z1 എടുക്കുക. What is E of n1? What is E of n1? Minus m e raised to 4 divided by 8 epsilon 0 square h square into 1 by n1 square. What is E of n2? Minus m e raised to 4 divided by 8 epsilon 0 square h square into 1 by n2 square. What is delta E? the spacing between these two energy levels. That is the corresponding energy which will be emitted when an electron jumps from this level to this level. So this difference will be m e raised to 4 divided by 8 epsilon 0 square h square into 1 by n1 square minus 1 by n2 square. എങ്ങനെ ഓർഡർ തിരിഞ്ഞു വന്നത്? ഇവിടെ ഒരു മൈനസ് ഉണ്ട്. സോ en2 മൈനസ് en1 എടുക്കുമ്പോൾ en1ന്റെ ടൈം പോസിറ്റീവ് ആവും. അത് ആദ്യം എഴുതി, മറ്റേത് നെഗറ്റീവ് ആയി. സോ ദിസ് ഈസ് ഡെൽറ്റ ഇ. Then what is the frequency of radiation? Corresponding frequency we already discussed that delta E is h nu. So nu is equal to delta E by h. So that becomes m e raised to 4 divided by 8 epsilon 0 square h cube into 1 by n1 square minus 1 by n2 square. Now we can express it in terms of wave number. We have nu is equal to c by lambda. So 1 by lambda is this delta E by hc. This becomes m e raised to 4 divided by 8 epsilon 0 square h cube c into 1 by n1 square minus 1 by n2 square. This I can express like this. 1 by lambda, usually represented as nu bar. This is called the wave number. It is equal to RH into 1 by n1 square minus 1 by n2 square, where RH is mass of electron into e raised to 4 divided by 8 epsilon 0 square h cube c. 8 epsilon 0 square h cube c is called a Rydberg constant. What is its value? Its value is 1.097 into 10 to the power 7. 1.097 into 10 to the power 7 meter raised to minus 1. Because its unit will be 1 by lambda. 1 by lambda is 1 by length. So RH will have a unit of 1 by meter or meter inverse. This is the value of Rydberg constant, 1.097 into 10 to the power 7 meter inverse. So I can write 1 by lambda is RH into 1 by n1 square minus 1 by n2 square. This is the equation for finding the position of lines in hydrogen spectra. Now, we can give different names for these lines, and the first one is called Lyman series. That is, you have n1 is equal to 1 and n2 can be 2, 3, 4, 5 up to infinity. That is a transition from 2 to 1 or 3 to 1 or 4 to 1 or infinity to 1. All these are called Lyman series. So I can write 1 divided by lambda is equal to RH into 1 minus 1 by n2 square. What is the position of first line? First line means n2 is equal to 2. നോക്കൂ, ഞാൻ ഈ ഫിഗർ വരച്ചതിനകത്ത് ഏതാണ് എന്റെ ഫസ്റ്റ് ലൈൻ? ഞാൻ ആദ്യം വരച്ച ലൈൻ എന്ന് പറയുന്നത് n ഈക്വൽ ടു 2 നിന്ന് n ഈക്വൽ ടു 1ലേക്ക്. അപ്പൊ ഞാനിവിടെ എന്റെ എൻഡിങ്ങിനെ n1 എന്നും സ്റ്റാർട്ടിങ്ങിനെ n2 എന്നുമാണ് റെപ്രസെന്റ് ചെയ്ത്. അപ്പൊ n2 ഈക്വൽ ടു 2 നിന്ന് n1 ഈക്വൽ ടു 1ലേക്കുള്ള ട്രാൻസിഷൻ. ഇതാണ് ഫസ്റ്റ് ലൈൻ ഓഫ് ലൈമാൻ സീരീസ്. All these are termed as Lyman. This all lines together called Lyman series. Its first line is this one, and last line is this infinity to this one. This is last line. So first line, I can calculate it like this, N2 equal to 2. This implies 1 by lambda is 1.097 into 10 to the power 7 into 1 minus 1 by 4. Okay, or lambda is equal to 4 by 3 into 1.097. Let me write it like this, 4 divided by, okay, 4 divided by 3. And this you can calculate, if I substitute the values, it will be something like 4 divided by 3 divided by 1.097. It will come around 121.5 nanometer. 121.5 nanometer is in the UV region. What is UV? Ultraviolet. If you look at the range of various radiations in the spectrum that I already discussed in the first class, 121.5 lie in the range of ultraviolet. The Lyman series first line is in UV region. What about last line? What about last line? Last line is obtained by putting N2 is equal to infinity. That means 1 by lambda is equal to 1.097 into 10 to the power 7 to 1 minus 1 by infinity. 1 by infinity is 0. So lambda is simply 1 divided by 1.097 into 10 to the power 7. And it will come around 91 nanometer. So this is also in UV region. So we can conclude that the Lyman series lies entirely in the UV region. It is a very narrow range, 91 nanometer മുതൽ 121 nanometer വരെയുള്ള 30 nanometer സ്പേസിങ്ങിലാണ് ഈ ലൈൻസ് എല്ലാം കിടക്കുക. Okay, so this is all about Lyman series. In the same fashion, you can explain what is Balmer series. What is Balmer series? Consider all the lines end up in 2. That is 3 to 2, 4 to 2, 5 to 2, 6 to 2, 7 to 2, then up to infinity to 2. So all these end up in n is equal to 2. These are called Balmer series. Balmer series. You can calculate the position of first line and last line, and you can identify in which region it lies. In a similar manner, you can explain the spectrum in which the lines ends at n equal to 3. It is called Lyman Balmer fashion, then bracket fund exit point. Okay. So this is the idea of hydrogen spectrum. So using Bohr atom model, we can successfully explain. We could successfully explain hydrogen spectrum. Okay. So you do yourself the calculations for Balmer and the rest of the series. We will discuss it next class. Is there any doubt? Is it okay?
മനസ്സിലായി.